So we will use this table up here for our show and tell. Looks like we have a good video shot of this workout good. Alan, would you like to start?
Because it's working.
Great.
And it won't work for long. So anyway, let's see, this is serendipity. I got a call, I guess Monday last week, from Tech Shop saying, there's a guy who heard you talking and he wants to talk to you. I said, okay. Turns out he works at HP Labs. He heard me teaching a class, and it was an Arduino class, but I was talking to the class about interfacing BeagleBone Black to the Arduino. And it turns out he's at HP Labs, they build printers, and they're interested in using BeagleBone Black in point-of-sale printers. So they called me and they say, what do you know about the Brew chip on BeagleBone? And I said, nothing yet, but in 2 days I will know something about it. And it turns out it's very interesting because the Brew is I guess, peripheral real-time unit. It's how the hardware interfaces off the BeagleBone. And it's interesting because, to make a long story short, it's very complicated to get it working. And it's very specific on the kernel flavor, and there are millions of kernels. And because it became so complicated, Linus Torvalds threw a fit and said, we're not building a separate kernel for every different flavor of ARM. We have one general ARM kernel, and then you interface it by a peripheral called DTC, Device Tree Chain. Anyway, after 4 days of hacking, I actually got an LED to blink. And so we actually have two LEDs to blink. So I have digital input and output. I have the red one blinking. And I also have ROS on this. So ROS is running the ROS Arduino bridge. Wonderful software written by Patrick, and Jim Nugent worked on it. So that's the yellow LED. And the digital output through the Brew bus, through the Bone Cape Manager, is blinking the red LED. And so far I haven't figured out the analog or UARTs or anything else, but I'm on my way.
All right, who else has a robot? I thought I saw another hand over. This is Mark. Is that you?
I can do it now, but how about the kids?
Okay.
Any of the kids want to go?
Is it,
Anytime.
Mark wants another minute. Anybody else? I think you're up, Mark.
Okay. I need a clear table.
Okay.
So
Okay, that sounds good.
last month I showed a different robot. This is an earlier robot which is not using ROS and not all the fancy multi-processes and all that kind of stuff. But this one has some intelligence. So this is called Motobot. And I know, not very original. I write up whatever is written on these things and talk about different circuit techniques and so forth on mark-toys.com, if anybody cares. So, so can you zoom on this real fast? That's all right. When it comes up, the LCD turns on, and then he starts working in stay on the table or you're dead mode, which is pretty normal. So, except for in order to do that, you got to turn on the little power switch for the motor drivers. So I just replaced the old motor drivers with new motor drivers that are DAC based, which are really awesome. There's a thing called a H-bridge chip that does bidirectional motor driving over I2C, which is an interface for almost everything I use. And now when he hits 2, he turns around and avoids in a certain way. When he hits only one side, he does a partial turn and continues on his way. So far this is not very exciting, but if you look at the display and so forth, you would see that he has an electronic eye. It's a cyborg eye that is a linear sensor. And he can tell if something is to the right or to the left of him if he sees it. Once he sees it, that's when it gets fun. So this is what he looks for. Can you see this?
Yes.
See, it's easier for you because you're human. But He's going to, hey, isn't this part of the challenge? Has he made it to the other side of the table?
Yes, that's phase one.
Okay. No, he decided he wasn't going to go there. Wow. I don't know what he saw.
Close enough.
All right, so what we're going to do is I'm going to place something here that's the thing that he looks for. He has a narrow field of vision. His field of vision is about 4 degrees. I've got some more sensors that are going to allow him. Okay, now he's seen it. Now if you look, no, he hasn't seen it. He's still in roam mode. There. Now you see him going back and forth. He's creeping up on it, getting it into his comfort zone. This is where he wants it to be. Now, if I move it away, he says, oh, it's a little farther away. I'm going to go find it, okay? If I move it closer, he says, whoa, I'm sorry, I'm not that kind of robot. So he backs away a little bit. Now, the other cool thing is he follows it. So if I go one way or the other way, he follows the little LED. Now, the other cool thing is if he knows it's going in one direction, but he loses it, he keeps going in that direction until he sees it, and he creeps back up on it again. That's what he does. That's his life. Thank you very much. Oh, and this particular one is not being Ross or anything. This is a PIC chip, PIC microcontroller, coding in C, that sort of thing. So it's old school. Interrupt operating system. The interrupts deal with the acquisition of the, this is proprietary technology here, this eyeball, this cyborg eye. So he does all that in interrupt, that goes to the background task inspects that stuff and acts on it and moves right or left, etc. Okay, thank you.
Very nice. Okay, who else has a robot that they would like to show? Okay, let's go to this side, and then we'll come back over here.
Which was a goal.
Camp.
Hi, this is a TurtleBot, and he's running Ross.
Woo,
Some of the stuff we
TurtleBot!
talked- Yeah, there you go. Thank you, Melody. We've got some TurtleBots floating around the club. Alan Fetterman, raise your hand, please. Dr. Alan Fetterman, that is. Willie, he's got Willie. That's the club TurtleBot. And Ted Larson here has a few TurtleBot ones, right? Available.
Yes,
Ted, raise your hand.
They're available for adoption.
They're available for adoption. This is Robot Rescue.
But if you want one, you can contact me or come find me at the club.
Raise your hand. Turn around.
Over
He's the
here.
guy. He's the guy right here. And Dr. Alan
What the
Fetterman.
deal is, if you take one, you have to come back with it working, doing something. You can't just take it and put it on a shelf.
Yeah, so like this TurtleBot here is basically a create base. Melody, you designed this, right? Willow Garage designed this.
Tully and I did, yeah.
Yeah, okay. Tully Flip and Melanie Wise, ladies and gentlemen. Great little Ross platform. We're all talking about Ross tonight. And if you really want to get your feet wet, contact Dr. Alan Fetterman or Ted Larson. Get yourself a free TurtleBot, computer not supplied. You have to format up a computer with Ubuntu and load the Ross and have some fun. Join the mailing list. We have a mailing list here. Everybody knows that? Yeah, okay. hprobotics.org. We have a mailing list. It's a great mailing list. I want to talk about one more little robot here. This is part of my challenge, okay? I've been playing around for years with a theory in machine intelligence by David Heiserman. And last month I talked about it and I said that I was going to bring Rodney Jr. to machine level gamma. There's alpha, beta, and gamma, 3 levels of machine intelligence. Anyway, this is like alpha right here, where he's just bouncing around, trying to go either forward or backwards. He's using this encoder wheel, this Roomba encoder wheel here. But anyways, right now it's just alpha, where he's trying random motion patterns, trying to go forward, to discover forward or backwards, although my encoder's not quite right there. In beta, and I'm going to spare you the theory right now, that's my challenge, is to have this ready for next month, is at least I'm going to have this to beta level. I keep saying I'm going to have it at gamma level, I'll never do it, so I'm just going to challenge myself to do one step this next month, and come next month I'll have that for you. Chris, did you want to talk about the DARPA Watson.
Sure.
He's got a. We tried to do a segue here in machine intelligence, artificial intelligence, or as Dave Wyman prefers to call it, applied intelligence. Is that right? We don't want to get into a fight here. All right, go ahead. It's Jason, right?
Shane.
Shane. All right, Shane. Shane, ladies and gentlemen, and Chris. Part of Team Walk Like a Man. These guys are involved in the DARPA Challenge. The street crew, right? Here you go.
Got a robot strap.
There you go. That's quite a necklace. You want the microphone?
No, I'll just shout.
You want the microphone?
Unfortunately, we don't have the stand, so I'll have to hold him. And what we're hopefully going to do is we're first going to talk about sort of what we're doing. He's going to show a couple of movies of the machine learning that this guy does. And I just finished this software it compiles 2 minutes ago. We're going to try it anyway. Cross our fingers.
It's like
No, it compiled.
it's like
It compiled. So anyways,
Without errors.
the idea that we're working on now is we want Watson to be able to learn his own animations rather than doing pre-sequenced animation data. We want him to actually learn how to do it on his own completely autonomously. And to that end, I wrote some software that starts from absolutely knowing nothing. And I kind of say it starts off twitching like an epileptic baby, but it quickly learns, and if you give it a goal that you can define mathematically, it will converge on a solution. So the first thing that we just got working this last weekend was a simple test, learn how to flip over. So we'll show you the...
You switch to the...
Yeah, switch to that, and we'll show you a quick video of him learning how to flip over. Now keep in mind, he doesn't even know anything about his own body. All he knows is I have 15 muscles that I can twitch, and I have one IMU that tells me which way is up, and that I've moved, and that's all it knows. And then we want it to learn how to flip over.
Yeah, do I switch it to the
Yeah, so can we
HDMI
switch
input,
to
or-
his HDMI output? Yeah, there we go. So this is done in the VREP simulator, and
So this one's starting on his back, and he's going to spaz randomly.
so this is him trying to do basically random things. With each trial, he learns what doesn't work. He slowly builds up a model of himself and his environment, and he will learn how to flip over. Of course, this is stuff that's been done before, but it's new to me, so I'm excited about it.
And the only bounds we're giving him are the bounds of his circles
Yeah.
and the goal.
Now, the first runs that I think I showed some of this off last month, it took somewhere on the order of hundreds to 1,000 trials to learn something simple. With the new software, he learns this in only 9 tries.
Wow.
He's getting close.
So he's getting close, which is why we can show you the video. It only lasts a little over a minute.
Does it cry or something?
Not yet.
Is this a live simulation?
No, but
This is a video, but we are going to be showing a
Great
live
moments.
simulation of him learning how to walk.
That's great. That's cool.
Where did the software come from?
My brain.
You did it.
I have a little bit of brains too.
What happened? Did he flip? Is that the end of the movie? Did he flip over? I missed
Did he
it.
flip? Okay, watch. But this is what we.
Now are we live?
Yeah, now we're live.
So this is VRAP Live Simulator. We've cleared his brain. He knows absolutely nothing. We're going to start him standing up. And of course, he's going to fall down a lot. But eventually, he will learn to wobble. He will learn to walk, but that takes a little bit longer. We'll just show you getting to the point where he wobbles.
And the only bounds we're giving him here are keep your chest above a certain level, and we constrict his maximum sum of changes, so he can't
Yeah.
do the craziest thing. But other than that, it's
Yeah.
pretty darn random.
Yeah. All he knows is the IMU is in his chest, and when it goes
Let's see.
halfway from where he starts, he he thinks he fell down, and he'll start again. So are we running?
Mm-hmm.
So he starts off absolutely knowing nothing, and everything he tries, he's probably going to fall down. But he's learning. The algorithms, it's a homebrew combination of a Bayesian recognizer that's running a genetic algorithm that goes to the inputs of a two-stage feed-forward neural network.
This is live right now, so
Yeah, this
see what
is
we
him
get.
live. The goal is to run this, of course, not in real time, but to run this rapidly, to have the robot be able to do this 1,000 times and learn an animation that it didn't know in real time. So you would be able to give it a simple goal, such as kick that soccer ball into the goal, and it will autonomously do it. And we'll just let this run for another minute or so, because it does take him a while, but he does eventually start to wobble around and then start to walk forward. Yes?
Are you modeling like sensor noise in the simulator?
At the moment, there's noise on the servos, but no noise on the sensors.
Okay.
And then just the non-deterministic nature of the physics simulation introduces some noise.
Yeah, but you're right. We will get to the point where we model the noise. A second phase, once we have him learning how to walk, is we want to take the animation data, which is what I just compiled, and put it on the real robot, and using either the IMUs or through motion capture, find what's the delta between the animation and reality, and then train a different neural network to update the internal model of the robot so it actually learns to make the model match itself better. So as it does things, it will learn how to make the simulation be a better representation of real life. Because the biggest problem, you can solve problems in a virtual world fairly easily. As soon as you bring it into the real world, that's where it's hard. So anyways, while that's playing, I'm going to hit go.
And this is just playing
This is the first time with first
cycle of
software,
physics.
and he's just going to cycle through one of the animations that he learned how to walk with. However, I don't know if I have the servo numbers right.
Well, let's see now.
We'll find out. He needs power.
It does need power.
So you plug him in, and I'm going to let you be ready to pull power if he looks like he's going to hurt himself. Which is why we do this in a simulator. So go ahead and power him up. And let's see. Oh, pseudo.
4 steps.
Can you hold it for a minute while so I can type?
Seems like you almost might want like a sort of a roll cage around him or something to protect.
This was made about 2 hours ago.
Yeah.
We had a harness
yeah.
for him.
But I have no confidence in myself.
No, I'm finding it. Are you ready?
I need 2 hands to
He's
pull the cord.
initializing servos. He found the hardware. And only one leg is moving.
I'm barely holding it. It's pretty much standing.
When you say found the hardware, what do you imply?
Oh, that it connected through the I2C bus to the servo controller.
Because
I just wanted to make
he
sure.
knows he has these numbers of servos.
He knows how many servos he
He
has.
doesn't know what they do.
He doesn't know what they do or the
Right.
configuration.
But he does know where those servos are on the I2C.
Yes. So basically, the neural net controls 15 muscles, and its sensory input is just the IMU.
Got that. I just wasn't sure if he was also trying to discover.
I can tell right now, just by looking at his feet, that the indexes to which muscle doesn't match what was in the simulation. My apologies. So he won't actually play the real data. He will, but on the wrong muscles. So yeah, we might as well just pull the plug.
Bring it back next month.
But next month, hopefully
That's
he
your
will
challenge.
take part of the robo dancing and we'll have him dancing. Thank you.
So let it run and plug it in like an hour and see how far it gets.
Assist there.
Thank you.
Thanks.
And anybody wants to help, we'd love your help.
All right, we'll continue with our show and tell. I know we had a robot over here. Would you like to go next? We have a box. Hopefully there's a robot in the box.
Is there a robot in the box?
Hopefully something is in one piece.
Bot in the box?
It's a Schrödinger box. Robot or not a robot?
Yeah.
My excuse is this is my first bill. I took the robot class at the beginning of the summer, and I've kind of lost touch since then, so I don't know if there have been other classes, but I did try to get here once and ended up in the Shoreline parking lot with 3,000 rock fans. So, at any rate, for those of you that don't know about the course, it was really good. In 4 days, you actually produce something that works. And now the kit, it's completely kitted, and a lot of the stuff is printed in it. The body it comes with is just an 8-inch square pegboard, so I did a little bit of hacking on it. So I have a plastic body, it's a little prettier. And in the class, basically, we do the follow and the edge detection and so on. I wanted to try something a little bit differently, a little different, and it may be different enough that it doesn't work here. And, what I wanted to do is I wanted to take just one of these sensors and see if I could implement some kind of a real simple-minded gesture system. So I will try that, and I must tell you that this robot is not table trained. So I don't know how well he will stay on the table. It's all going to be sort of random here. Oh, by the way, this is an adaptive system. That's the system, and I'm the adaptive part. The way this works is basically I'm using this thing essentially as a space filter, and there's a certain range over which he detects something. Past the range, he doesn't look at it. And there's sort of a near field and a far field, and basically I go between them and do 3 different positions of the thing, and they're encoded as scripts, and the scripts are simple commands that it understands. So let me try to see if I can get it to do a twirl here. That's it, basically saying it gave up. Okay, we'll try once more. That's my feedback, and I'm not interpreting it right. Okay. Oh, operator error. That's what happens when you have 2 switches to control one function. There's a 50% chance you're not going to get the function. Well, that's kind of it. It does have a couple of other behaviors, but I just wanted to try that.
We have a request to see it again.
Do it again now that
It's on.
You have more faith in this than I do. Okay. I'll try to do the twirl one again. Okay, let me explain what's going wrong here. Basically, there are 3 time samples that are taken, and the short beeps from the piezoelectric speaker let me know when I'm at the end of one of those, and I should shift position. When it's gotten all 3 samples, I get a longer one, and then it has a refractory period it goes through, and then when it's ready, it gets a longer one. So I kind of get out of sync with this stuff here. I think it's ready now, so we'll try it. Okay, supposedly that worked. Yeah, I better start.
Very nice, interesting concept. I know that if it wasn't working quite as you had expected, it might be because there's ultrasonic noise in this room. I know we had a lot of problems with noise in the cafeteria room that we were in at Google last time.
Well, that was all operator error, that wasn't.
Okay, are there any other robots for show and tell? Okay, well, you guys are thinking. I brought a robot that I've been working on, as I mentioned. The goal of this club is to build robots. This is one that I started working on. It's not operational yet. But somebody posted a message on the club mailing list a few weeks ago about a contest that Servo City is having to build a balancing robot out of their parts. So Servo City sells this kind of kit stuff. They call it Actobotics. It's this aluminum channel, and they have pulleys and brackets and all kinds of things that you might need to make a robot. It's kind of like a erector set for robots. So what they said was that you have to build a robot just using their parts or parts from their vendors, which include Pololu and SparkFun. So, I had built a balancing robot before, and it looks like they had a nice selection of parts, so I thought, how difficult can it be? Well, it's actually quite difficult to build a robot using a restricted set of parts. I'm used to going to the DigiKey catalog and picking whatever I want. But when you have to use a microcontroller that's, one of maybe 3 choices, it doesn't give you a whole lot to work with. But this is what I got so far. It doesn't work yet, but the contest ends in about 2 weeks, so I need to get moving. So hopefully maybe at the next meeting I'll have something running. So that's what I got. Are there any other robots?
I got a question.
We have a question, yes.
After you spend $500 on all these parts, what's the prize?
Well, my wife has asked me that too. She sees these boxes keep showing up at our door and wonders how much this is costing. I'm telling her it's maybe like $10, $20, no more than that.
Yeah.
The prize is actually $1,000 worth, but it's worth more parts. I think what they intend to do is have more contests down the road. At least that's what they've told me. So this is just the first of several different contests. So if I get $1,000 worth of parts, that will certainly help me with the future contests. But it's good. Their idea is similar to like the X Prize. At the X Prize, people give out $1 million prize for achieving some goal, but the sum total spent achieving that prize is way more than $1 million. And so this is kind of like the Servo City X Prize.
Paul Allen spent $20 million to win 10.
Yeah,
and then he wouldn't even take a ride in a spaceship. So.
Yeah, I'll probably spend at least $500 to hopefully win 1,000. So I figure I've had a 1 in 2 shot, so it's even chances there. All right, I think what we'll do now is we will take a short break, and then after the break, so it's 7:46 right now, we will break till 8 o'clock. That will give everybody a chance to come up here and get organized. At 8 o'clock, we'll start with the team who won the IROS 2014 Microsoft Connect Challenge. They will show their trophy, as well as talk a little bit about their robot, how they won the challenge, and what the challenge was for. Should be pretty exciting presentation. So, and that will lead directly into our ROS panel